This is Mr. Beck Does Your Homework. This is AP Physics, homework 3.1 on balanced forces. This is question number 9. It says, consider the 193 Newton light fixture supported as the figure. Find the tension in the supporting wires, answer in units of newtons. So, free body diagram, I have a force of gravity down. I have a tension pointing in this direction. I'll call that Ft2. And I've got a tension pointing in this direction, which is Ft1. Now, I've got a tension here, and gravity, and somehow they all balance out. So I know that whatever's pulling to the right must equal whatever's pulling to the left, and whatever's pulling up must equal whatever's pulling down. Well, my force of gravity is down. What's pulling up? This is kind of pulling up, and this is kind of pulling up. So each one of these tensions can be split into, this one could be a tension in the x world, so Ft2x, and this one would be Ft2y, lots of subscripts. And the other tension that's pointing in this direction could be split into a Ft1x and a Ft1y. Get all that? So this tension, this real tension, is split up into these components. This real tension is split up into these components. Now, if I have just my components on a free body diagram, that would show me that I've got gravity down. I would have tension 1 and a tension 2 in the y direction. I would have a tension 2 in the x direction and a tension 1 in the x direction. So this is Ft2x, this is Ft1x, this is Ft1y and Ft2y, both pointing up. Well, I know that left equals right, so this one must equal that one. I also know that this is a 36-degree angle. So this right equals this left, so that's good. But now my up and down is what I'm really interested in. So I know that my force of gravity, which is down, okay, so this is the downward forces, must equal all of my upward forces added together. And upward, I have, follow this, Ft, the tension, number 1, in the y world, plus Ft2 in the y world. But aren't these two going to be equal? Since these two are equal and the angles are equal, that means that I've got some similar triangles, and so this is going to equal that. So really, I can just talk about force twice the force of tension in the y direction. So my force of gravity is going to be twice the force of tension in the y direction, because these are going to be equal. So the force of tension in the y direction is going to be half of the force of gravity. So really, this is going to be split in between them. But now, what is the force of tension in the y direction? Well, if I've got a right triangle there, I know that this is going to be my total force of tension times the sine of the angle. So I also know that my force of tension in the y direction is going to be my overall force of tension, which I'm looking for, right? That's what the question is asking, times the sine of the angle. So I'm going to plug this in where I had this. So now I've got my force of gravity equals twice my overall force of tension times the sine of the angle. If I rearrange that to solve for the force of tension, I get, over here, I get my force of tension is going to equal my force of gravity divided by 2, also divided by the sine of the angle. My force of gravity is the newtons, so for me that's going to be 193 newtons, divided by 2 times the sine of the angle is 36 degrees. Wait a second, did I do something sneaky in there? I did, because I used this angle, but if I draw that over here, I know those are opposite internal angles, so that's also 36 degrees. So I was a little sneaky, but I snuck it by you and then I explained it. So that's how you're going to get your force of tension. And you're not going to double it or anything, but that is your force of tension in one cable, in the other cable, in either cable.